Have you ever wanted to understand IP networks or just unravel its concept? If that's the case, well, this video is for you. Do you know how much IP device you have in your home network? Well, I do. I just checked this morning. It's 58. That's a lot of IP device. Even your fridge today can have an IP. Your phone is going IP, your TV is going, everything is going IP. So understanding IP network can be very useful. Mainly if you are an amateur radio operator like me and want to do project, understanding IP become very much important. If you are new to IP or just wanted to learn, this will give you the basic on how IP networks works. If you are a specialist, well, this video maybe will give you some simple explanation to help others understand IP. So we will only scratch the surface of the subject because every subject can be a book or a chapter in a book. But in IP network world, the first thing is to back up a little and see a high level vision of what is an IP network. And that's what we're going to do. And the simple explanation I'm going to use is to make you understand the relation with a concrete explanation, the relation between all those protocols, which become very important, especially if you have a problem and want to troubleshoot. Since I was in college, I had many courses about digital communication and mostly IP networks. And all those courses started with the OSI model. The OSI model is the foundation of your knowledge. It is the most important thing. And a lot of technicians, they neglect that part because they say, no, it's just theoretical, things and it's not practical, but it is very practical. That's the basic. You need to understand that. You can troubleshoot and find problems like this just thinking about the OSI model. The OSI model consists of 7 layers that explain how protocol exchange between each others. This is an old model. If you look at my handbook that I have here, which is the 1993 edition, and you go in it, you will find the OSI model at least at 2 places into the book. And this is very important, is the basic. You need to understand that. That's why every course started with the OSI model, which is the Open System Interconnection model. Before going to the detail of all the different layers, please note that there is also another model commonly used other than the OSI model. It's the TCP IP model, or often called the TCP IP stack. This model combines layer 5, 6, and 7 of the OSI model into the application layer. They also call the layer 3 the internet layer, and they combine layer 1 and 2 into the network interface layer. For the purpose of this video, I will concentrate on the first 4 layers of the OSI model, but use only one layer for the application layer, like the TCP IP model. The first layer is the physical layer. This is easy to understand. Here you have a network cable, which is a physical layer, coax cable, fiber optics, even RF of a Wi-Fi connection is on layer 1. You probably wonder why there is a kitchen set right in the middle of the screen. The kitchen set will be used to explain the different layers and the interaction between those layers in my example. In this example, on layer 1, the chair and the table are actually the physical layer. Let's move to the layer 2. The layer 2 is called the data link layer, and what we have here is the Ethernet protocol. On layer 2, we say that we are switching and we are switching frame. Okay, so this is the switching layer. The kitchen set in our example is actually your LAN, your local area network. So every device is connected, wired or via Wi-Fi to that LAN. Every furniture has a specific position around the table. For an Ethernet network, this will be an example of a MAC address that is unique, and the MAC address is 48 bits it looks like this, okay? But don't worry, you don't have to learn how to handle those addresses. You just need to know that is an hexadecimal address of 48-bit that looks like this. Otherwise, you don't need to learn this. But keep in mind that every Wi-Fi interface, every wired interface has a different MAC address. Even if it's the same PC, the Wi-Fi interface on the same PC will have a different MAC address than the wired interface. Using the table example, so everybody can talk to anyone directly while sitting at this table. Why? Because switching is very fast, so it's in the same network, so we can communicate with everyone. In this video, we won't talk between the difference between an intelligent switch and a hub. This is not the purpose, okay? But just keep in mind that switching is very fast and direct, and everybody can talk to everybody at the table. So if you talk, everybody at the table can hear you. This is called the broadcast domain. This is important. This is the broadcast domain of your LAN. It's like everybody sitting at the table can talk to everybody directly, but he can also shout and everybody at that table will hear him. Keep in mind that Ethernet IEEE standard always start with an 802. So if you have Wi-Fi N, which is 802.11n, this is an Ethernet protocol and this is layer 2. If you have QoS at that layer, what is called quality of service, you can do QoS between VLAN or ports, okay? So this is 802.1p. You also have the trunking starting by 802.1q. This is more advanced thing about Ethernet, okay, or layer 2 protocols, but it's just giving you an example that everything starting by 802, it's on a layer 2, okay, and it's related to Ethernet. Let's continue with layer 2. Remember what we said. This is one broadcast domain. Everybody can talk to anybody sitting at this table. This is your home network. As in this example, let's say your network B, and your neighbor is network A, and this is your neighbor's house. They also have a network, they have a table, and every device connected into that broadcast domain is sitting at the kitchen table. But if you want to talk to your neighbor, you can't. You have to move the other side and go to your neighbor with your device, okay? But if you're here, you're not in this broadcast domain anymore, so you won't be able to communicate with them here. So you need a process to be able to talk to your neighbor broadcast domain, okay? So that means when you have a layer 2 network, we usually isolate broadcast domain using routing. In this example, it's the continuity of the previous slide. It is actually the same, except the WAN is the outside network, okay? So it could be your neighbor or anything outside your broadcast domain, outside your network. So there's two different layer 2 Ethernet network on the WAN side and on the LAN side. The WAN, by the way, is the wide area network, and the LAN is actually the local area network. Both networks have two different broadcast domains, and to communicate between A and B, you will need a routing process. So let's move to layer 3, which is called the network layer, and what we'll be talking about here is IP address. You can see on the diagram that we still have the WAN and we have the LAN, which are two different networks, okay? A router will have a WAN interface and a LAN interface. This is a business router, but in a common home router, you will have only one WAN interface and you will have 4 LAN interface, and the 4 ports in the LAN interface are sitting at the same table. This is your local area network, and it is the same broadcast domain. The WAN interface is in another network and in another broadcast domain. So on a layer 3 basis, a router will have a WAN and a LAN interface, okay? A WAN is the outside interface and the LAN is the inside interface. But it is two different IP networks. And on a layer 3, we are routing. We are routing between A and B. And we are routing packets on a layer 3. Let's continue with layer 3. Now we will be talking about IP addresses. There is two types of network that is used currently. It is the IPv4, that stands for Internet Protocol version 4, and IPv6 for Internet Protocol version 6. Don't ask me, there is no IPv5, okay? It's not used, but we won't be covering that in this video. There is IPv4 or IPv6. When they started with IPv4, with the internet growing very fast, they were afraid that they will be running out of addresses. So what they did, they invented IPv6, which consists of a lot more larger network that can actually give an IP address to every square feet of the planet. But de-addressing SHEM is very complicated. It uses hexadecimal and it looks like this, so it's not very user-friendly. But they also invented in the IPv4 what they call the NAT path that use private and public addresses. This prevents them to run out of address. That's why we still are using today IPv4. So we will concentrate in this video in the IPv4. An IPv4 address consists of 32 bits. So if you look at as a binary code, it will look like this. It will have either 1 or a 0 and a 32-bit long address. Okay, so it starts from all 0 to all 1. Remember that in binary code, it's either a 1 or a 0, and you can have a combination of over 4 billion possibilities with a 32-bit address. For humans, binary is very tough to remember, so we did convert every 8-bit in bytes. That's why we have address that we can convert in number. If we go with 8-bit, it's either all 0, so it's from all 0, or from all 255. Because 8-bit, if you do all the possibilities, you will have 256 possibilities that you can do with 1 and 0 on an 8-bit binary code. Okay, so that's why you have 256 possibilities from 0 to 255, and that's why you will never see on an IPv4 address a number higher than 255. Subnetting. Okay, now if you want to subnet the whole network, okay, you can do smaller network, which is called subnetwork. Okay, if you want to do a subnet, the most commonly used that you have on your own network, it is a /24, which means 32 minus 8, that's come to 24. That means the first 24 bit will never change, only the last 8 bit, giving you a possibility in your network of 256. And the net mask will be 255.255.255.0. That's why in the home network, you probably are used to see this network mask. Okay, so this is always the same because in the home network, it's usually a /24. Here, a subnet example of a home network, 192.168.1.0/24. So that means your network will be starting with 192.168.1.0 to 192.168.1.255. Remember, this is very important. The first address of a network or a subnetwork is always define the network, so it's not usable by any user or any device, okay? The last address is also not usable because it is reserved for the network broadcast address. So the first usable address will be the .1, and it's usually reserved for your home router that will assign its address to the LAN interface for this router. That will become your gateway, your default gateway into your network, and your home router will be the .1. The fact that we didn't run out of address is because they invented the public and the private addresses in the IPv4 network. Okay, so there's a concept of a class A, class B, class C address, which means a class A, it's actually a /8, which means that you have the 3 last bytes that you can use for your network, and you also have the class B, which has the 2 last byte that you can use as your network as a /16, and the class C. And they divided the internet addresses like this. So that's why the 192, then we have the class C with the /24. Only the last byte will be usable. This is the network mask for each type of network. Class D and E are reserved for specific application that will not be covered into this video. Private addresses. Because they invented private addresses, they decided that we will dedicate a class A address starting by 10, everything starting by 10 can be used by anybody to define a private network. Okay, so you can use that in your LAN. Even enterprise have enough address here to design a full network, a private network using a class A address. There's also assigned a class B that is 172.16 to 172.31. Okay, so this is the class B address. And the class C, which is the commonly used 192.168.0 or 0. Okay, that means you can change the number and create different class C network using the third byte here. Okay, so your home network could be 192.168.1.0 or 192.168.1 168.2.0 or 3.0 or 4.0. Okay, this would be different network. Okay, so but this can only be used in a private network, not in the internet. So if you have a subnet like this at home, your neighbor can have the same subnet and there won't be no conflict because you will have different WAN or public address on each side. So that isolate your broadcast domain. So your network can have private network here and the same here on the other side, okay, without conflict. That's why we didn't run out of address. But all the address starting by 10 or starting by 192.16 or up to 172.31, okay, the class B, or the class C 192.168, all those addresses are not routable into the internet. If the internet or an equipment in the internet, public internet, see this type of address, it will drop it because it's not routable. It's reserved for private use. Still on the layer 3, on the routing, now you have two different broadcast domain on the layer 2, but you have a router doing the routing between two networks. Okay, so you have a broadcast domain here, you have a broadcast domain there. This is your LAN. But if you type in an address that is not within your network, it will be sent to the default gateway, which is your home router, and you say, hey, where do I go with this address? And he will ask, is default gateway on the WAN interface, which is another network. It will route between A and B. So let's simplify. If your network B, you have a B address, you'll stay in B. If you ask for an A address, it will have to go out your network through a routing process with your router. The router has another broadcast domain on the other side, another layer 2, which is this network, and it has also a default gateway. And the default gateway here has another default gateway, and so on, and that's how you reach your destination. The subnet here, since it's a public subnet, it's been subnetted smaller than a home network, okay? Because we don't want to run out of address. So my subnet here is a /29. So only the last 3 bits are significant into this network. So that's giving me 8 possibilities from all 0 to all 1. And the first address is reserved for the network. So this is the network address. And the last address is reserved for the broadcast address. So that's leave me with the possibilities from 0.65 to 0.70 that are usable. And the first address has been assigned to my gateway. Okay, so this is not usable by me. It's usable, it's in the network, but it needs to be assigned to the device that acts as a gateway. So I started with the address 0.66.
So this is the first address I could assign to my router. Okay, so you have the WAN, which is the wide area network, and the LAN, which is the local area network. They are two separate layer 2 network, but they can communicate between each other using routing, okay, on the layer 3. Now, let's talk about DNS. DNS stands for Domain Name Server. Machine only understand IP addresses that are converted into binaries. As human, well, it's tough to memorize those addresses, so we prefer to use name. But your computer, in order to interpret what is the name and where it has to go with the name, need a process called the DNS server. So if you type in Google onto your browser, what it's gonna do, first, it's gonna ask its own router, okay, which is the default gateway. Hey, where I can reach Google? And the home router also have a configuration for the DNS that is provided by your ISP, your internet service provider. And this is your DNS. You can use other DNS as well. But he knows that when he see a name like this and a request from a machine within his network, he knows that he could ask the DNS server. So he will ask the DNS server contacting one of these two addresses. He will ask the server, hey, what's the IP address for Google? So he will send back, the server will send back the IP address. So the browser will be able to reach its destination. So domain name server are very, very important, okay? Because otherwise it won't work. And sometimes you can think that your internet doesn't work, but you didn't configure a DNS server or something like that, okay? So it's very important to understand that the DNS play a significantly role into those networks. Imagine if you add IPv6 addresses into your LAN, you will need a DNS server within your LAN to be able to communicate with your machine, because you won't be able to remember hexadecimal addresses, 128 bits for each device, okay? Dynamic and static IP address. There's two types of addresses that can be assigned to a machine. Here you have the WAN's interface for my router, which is a business router. WAN 2 is administratively down, okay, that is, I meant it to be like this. And then you have the first one as a dynamic IP address. That means it was not configured by me. It was obtained automatically by the network it was facing, okay? It sent a DHCP request and it received a dynamic IP address. So IP addresses assigned dynamically are using DHCP, okay? So they are automatically assigned by the network. A static IP, on the other hand, is an address that will never change, okay? This one can change because you can make another request and you can receive another IP address. But a static IP address is an IP address that has been configured manually. So you tell your router or your interface, this is your address, this is the mask, and this is your gateway. And sometimes you have to define the DNS as well. And a static IP address will not change, but it has to be assigned manually. And a dynamic IP address could change, and it's been assigned automatically by the network. Okay, so that's the difference between the two. DHCP, Dynamic Host Configuration Protocol. This is very important, and this concept is easier to understand using the first three layers of the OSI model. Okay? So when you connect for the first time a machine that you just bought at Best Buy, okay, let's say you bought a new laptop, you bring it home, and you connected either Wi-Fi or wired, okay, it doesn't matter. When you do a connection, you connect to the layer 1. Then your interface will be up and will get, your interface going to be up and you will have a link, and the link will show with the light there on the interface, or it will say it's connected. Okay, so then you have a link. Then you don't have an IP address, so you can't communicate with the default gateway or send a request to the internet. So what your machine's gonna do is gonna send a broadcast on a layer 2. Okay, that's why broadcast is important, to understand that it's a layer 2. It's gonna send a broadcast on layer 2, And it's going to say, hey, I don't have any IP address. Is there somebody that can give me an address? Then your home router that acts as a DHCP server, as you can see here, this is a snapshot from my router. The DHCP server is enabled, and it will assign automatically an address between this range, okay, via DHCP, and this is the DNS that it will send to the machine and the default gateway, okay, and the lease time, okay, which is 2 hours. So what happened is, let's go back, okay, so you connect your machine, you have a link, then it sends a broadcast on layer 2 because it doesn't have any layer 3 address to communicate. They say, hey, I need an address. Then your DHCP server will respond, hey, I can give you an address. It will send also a broadcast because there is no IP address to the host. So now it will say, yes, I would like an IP address. Then it will bond an IP address, like this address here, to the MAC address, okay, of the device. And then you'll be able to communicate on the layer 3 with that device. Okay, that's how DHCP works. So it's a process between layer 2 and 3. Okay, and this is the way to obtain an address. Or you can actually go in command line and just assign an IP address in that network. Make sure there's no conflict between another device, but you can do that manually. But most people are doing it like this. It's a lot more easier, and it's plug and play. If you ever get an IP address, okay, because I will show the command how to verify your IP address with your machine, at least in a Windows PC. And if you have an address that starts at 169.254, that means that you cannot reach a DHCP server, okay? So this, you won't have any connection if you have this, okay? Let's move to layer 4. That's where you will find the NAT path. NAT, which means network address translation, or an path, which is port address translation. You will say, network address translation, an address is on layer 3. The answer is yes, but this is a cross-layer process that allows, okay, that allows you to convert public address to private address. Okay, I will explain later on. On layer 4 is the transport layer. That's where you're going to find the UDP protocol and the TCP protocol. The UDP is the user datagram protocol and is mainly used for real-time application. UDP, there's no correction of packets. If you lose a packet, it will be dropped because there is no point of correcting a packet if it's not relevant in time. So that's where, when you're going to find some protocol that are using real-time application, okay, you will find UDP will be the mostly used. So you have, like for VoIP, 2 UDP session, and you will have the same thing with RoIP, which is radio over IP. This is voice over IP, but this is usually UDP, and it doesn't correct any packet drops or anything because it's real time. So there's no need, okay, to do correction. Then you have the TCP, Transmission Control Protocol. If you send an email with a picture and you lose a packet, you can send a request, say, hey, I want to reassemble the packet, I'm missing something, and the other end will send you the missing part. So there will be correction. So this is very good for something that is not real time, okay? I'm explaining that very, very simply, but mostly that's about it. And you will find TCP protocol being more emails, web browsing, and stuff like that. Then you have the RTP. The RTP are real-time transport protocol, and usually they call the media protocol, and they are assigned dynamically by the computer to do the communication. Okay, let's say you have VoIP, you have voice over IP, you're using a SIP. SIP are using UDP or TCP, depending of the system, 5060 or 5061 or 5060. Okay, that's the port for the session information and to exchange the communication, okay, about the session. That means this is the let's say the control port, but it will use dynamically some real-time RTP ports to be able to transport the voice or the video conference and stuff like that. Okay, but we won't go too much in there. It's just to understand, because if you want to do a port forwarding later on, you need to understand about ports. There's a total of 65,535 TCP ports and another the same amount for the UDP ports. An example of port, you have HTTP, okay, which is a common browser. If you type in http.laboenligne.ca, okay, HTTP, sorry, Laboenligne.ca or www.laboenligne.ca, okay, this is port 80. And if you have an HTTPS, let's say you use Google, it will be port 443, FTP is port 21, SSH 22, Telnet 23, and so on and so on, okay? So there is a lot of ports. Some ports are blocked one way coming from the outside world by your provider, but this will not be covered in this video. Layer 4, still on the transport layer. Now, let's look how it works when you use NATPAT, Network Address Translation and Port Address Translation. Since you have a private address shim into your LAN and it's not seeable on the outside world, you're using only one public IP address. Well, what's going to happen is your router needs to handle multiple sessions and it needs to assemble the packets to be able to route it to the correct device. This device is on Google and this device is on Facebook, and you're scrolling and clicking on things. It needs to know that it needs to send back to which machine the Facebook information or the Google information on the other machine. This is done via NATPAT on the layer 4, which is the transport layer. So what it does, let's say you want to come into my web page, which is Laboenligne.ca, that is hosted within my network. Let's say my server has this address here, which is the 0.5 of this subnet, okay? And the server port is 80 because the service of a web service is port 80. But if you try to go on the internet from this machine, what it's going to do is actually it will send the router the request for the external address, as I showed earlier with the DNS server, and the router will know when the packets come back that this information needs to go to this machine. But when you come from the outside world and type in Laboenligne.ca and you arrive here, the machine doesn't know where to send it, okay? So what you need to do is do a port forwarding. By default, by typing this in your browser, it's HTTP. Okay, HTTP, it's port 80. So you don't need to specify the port here. You know it will come on port 80. And the router won't know what to do with it if it doesn't know where port 80 is forwarded to into the local network. So the port forwarding, okay, you will have to set up on the WAN interface. You say port 80 has to go to the LAN interface to this IP address, okay, on port 80 as well. And if you do this, sometimes it's called port forwarding, sometimes it's called virtual server. But if you do this, you'll be able to enter from the outside world. That's why it's important to have a static IP address, because if it changes, you won't be able to get in. And you won't be able to use domain name except by using what they call dynamic DNS. We won't cover that, okay? But this is important to understand how port forwarding works. Otherwise, you won't be able to reach your destination from the outside world. But it will always work if the session is initiated from the inside of your local network. In the example here, I have the request coming on port 80, which is the default port. But here in my network, I use a different port, which is port 8080, because maybe I have another machine that I want to reach using port 80 in my local network. So the port forwarding will be the same. So port 80 coming from the WAN has to go to the LAN to the same machine, but port 8080. And now if you use that port on this machine, it will work transparently for the user at the other end. Another example is you will have, let's say your port 80 is blocked because you have a residential connection. Well, what's going to happen is you can set up a server on port 8080 and say, type in the IP address or the domain name with two dots like this, column, with the port number, and it will arrive here with the right port number, 8080, and then everything's from the WAN coming from port 8080. You did a port forwarding to the LAN to this address, and the port is 80. But it could also be 8080. But you see what I mean? You can actually play with this to make it work. Okay, so that's how NAT path is working. It's using both IP address of two network routing. Okay, so it translates the address and the port forwarding as well. This is my home router. Then you have the WAN interface with the dynamic and static IP address. Here you have the dynamic IP status of my interface here, and it shows that it obtained everything automatically, even the primary and secondary DNS from my provider. Here you have a virtual server, which is port forwarding. You have the port forwarding coming on WAN 1, port forward to 8080, which was my second example, of the port forwarding. And then you have the IP address and it's activated. You can also in your LAN do IP reservation. Now you see a pi star. Here you have a pi star and this is the IP address, okay? And this, I reserve this address to this machine. So when you connect a device for the first time, let's say you have an OpenSpot 2 like here, you connect to your network, it obtained 157. You went into your home router and you saw that this was the DHCP address that it obtained, okay? What you did is you actually copied the MAC and did this configuration. You copy the MAC here, you enter the IP address you wanted to have all the time, and you enter a name so you can now refer to this as the OpenSpot. And now what happened is it will never give this IP address to any other device, and it is reserved for this MAC address, which is unique to your OpenSpot. You see, that's why it's important to understand layer 2, layer 3, and all the relation with the protocol, because this makes you understand now that you can reserve this IP address. I get a lot of questions by viewers on how I do this. It's very hard to explain. That's why I decided to make this video. Here's a list of the DHCP client. As you can see, there's a lot of address that are permanent. Either I reserve it manually, okay, or I give it static IP address outside the range of the DHCP address, okay, that I use in my network. And this is the lease of 120 minutes, okay, so this address can change. This is not static, but everything that I need to connect as a static IP address, it's not a static, it's actually a reserve address. It's a MAC bonding with an IP address. This is the easiest way to have a static IP address into your network, okay. So, and the ARP list, this is the process. The ARP means they know they bonded the equipment, the router will bond the MAC address to the IP address. That's how he knows where to go when it has a request for a specific machine. It will, okay, so say on layer 3, this is the address of the machine you want to reach. So for me on the layer 2, I need to go on that port because that's the MAC address facing mine, and he knows where to brings the information, and it will come to layer 1 to the network cable, and that's how the communication will be done. Troubleshooting tools. Okay, on a Windows PC, there's already some tools you can use, very simple to actually troubleshoot your network. Now that you know a little bit about networking, you can go, this is Windows 10, you can go in command line. You type CMD here on the bar, and it will bring you to a prompt like this. If you type ipconfig, it will give you, sorry, my PC is in French, but if you type ipconfig, it will give you the information of what is your machine IPv4 address and IPv6, if there's any. It will give you the mask, which is always the same for a local home network. And it will give you your default gateway, which is your home router. So if you want to connect to your home router, then you need to type in this address in your browser, okay? And usually it should be on port 80, so you don't have to specify the port, okay? You can also do a ping. So if you want to test if you communicate with your default gateway, you can do a ping and it will answer. If you have this, it works, okay? By the way, here, I said it earlier, if you do ipconfig and you have an address starting with 169.254, it doesn't work. That means DHCP didn't work, okay? You can also assign a static IP address in your configuration of Windows, but this will not be covered. It's usually not necessarily. You can also use trace route. This command, trace earth, with an IP address or a domain name, okay, will bring you to the destination and show you the ping with every device you go through. Okay, here I went from my public IP, public access, internet access, okay, interface, and went to my business access, okay, which are with the same provider. So you see that I went outside the network and changed cable modem twice, okay, to reach that. Why I didn't try .66, which is my server? Because my router, my firewall is blocking ping, and if you're blocking ping, you're also blocking traceroute, okay, which is the ICMP packets is all the same for both command. So that's why I went to the gateway and to see the ping. But you can do that, a traceroute with Google, and sometimes the destination at the end is not reachable. It's just because the ICMP packets are blocked, the pings are blocked by the firewall at the other end. But this will give you an idea if you are going to the internet or if you are staying local, and it can be used for troubleshooting. Identify your router. Okay, let's say you have a home router, you don't know what is the subnet, you never connected to it, you just plug it and went, I don't know, you never configure it. Well, if you want to connect to it, here's a few brands, okay, you can do a pause to see that there's a few commonly home router brand that you will find on the market, and there is the common subnet they use, okay, by default with the default password and administrator username. So this can be useful. So this is the information. You can do a pause and try to find yours and to connect, but you can also do an ipconfig command and you will find your gateway anyway, but you will need to know the default password, especially if the router is new. Usually it is printed on it or something. So, but this is just for information. Troubleshooting with IP network. Okay, using the 4-layer. We talk about DHCP, so it's very, very simple to troubleshoot with the OSI layer. Why? Because it's giving you a process in your head. If you don't have any IP address, you have a 169 address, well, there's a problem on layer 2, okay? So you didn't get an IP address, it's not communicating, so you need to check the layer 2. Layer 2 will be the connector here to check if you have a link. If you do not have a light, well, there's a problem. Either the cable is not correct properly, the cable is defect, or the other device at the other end, let's say it's a switch, like here it's maybe the device is unpowered. If it's not powered, you won't have a link. So that's why it's down, okay? So you check the physical layer, is it connected, okay? And then you check, do I have a link? And then you check, did I get an IP address? And now can I go to the internet using my browser? So if you have an IP address, and you have a link, and you have a physical connection between your PC and the router, okay, your PC and the router. But if you do not go to the internet, you need to go on the other network, on the other broadcast domain, the other side. There's also a cable here, a Ethernet cable, going to your DSL or cable modem, okay? And this is also layer 3 because you have a public IP address, then you have a link with the cable with the 2 Ethernet port between the modem and the router WAN interface. And there's an address on the modem cable and an address on that interface in that subnet on the other side on the WAN interface. So it's always like this. So you check, do I have an IP address? Do I have a link? Is it connected? Is it connected? I have a link, I have an IP address, everything's fine. And this is how you can troubleshoot everything in IP network using this. So don't look everywhere if you do not go to the internet, if you do not have an IP address on your machine, okay? And there's probably no link because there's no connection, or maybe the DHCP server is not activated if you have a link and the cable is correct, okay? So this is a process of troubleshooting that can be very useful when you understand those layers and the interaction between those layers. Let's do a recapitulation. On the first layer, it's the physical layer, okay? And we can have different physical cable, type of cable to do the connection, or even RF or Wi-Fi. Then you are on layer 2, you have the switching. On the switching, we have a MAC address. That's where we have a link. There's a concept of broadcast domain, different broadcast domain between the WAN and the LAN, local area network, wide area network. Then you have the routing, okay, on the layer 3. That's where you have the IP addresses, okay? That's where you have your subnet. That's where you have your private versus the public address. The public address usually goes on the WAN, and the private address goes on the LAN. You can have a dynamic and a static IP address. One is assigned automatically, the other one is assigned manually. And you also have the DNS, making it easier to remember where to go when you want to go to Google instead of remembering an IP address. On layer 4, you have the NatPath process that's giving you the ability to port forward, to a virtual server, any packets from the outside to a specific machine in your LAN. You also have the UDP, TCP, RTP protocol that are used to transport depending on the application. And then you have the application like a web browser, which is port 80 on the layer 4, okay, and port 443 if you have HTTPS, which is the secure HTTP on the layer 4, okay? So this is the process that you have the full OSI model within your network, and this is helpful to understand what's going on with your IP network.
If you like this type of video, please let me know in the comments below, and don't forget to do a like. Also, if you're not already a subscriber, please subscribe, as your support is very much appreciated. And don't forget to click on that notification bell to be notified as soon as a new video is online. And maybe my next video will show you what's going to be on that empty shelf right behind me. So stay tuned for that. Also, please visit my website, which is va2pv.com, as you will find more information and some useful information about IP networks. Stay tuned, catch you some other time, and 73. Ciao.